Stream API is probably the most significant feature introduced in Java 8 9 years ago. It allows us to work with well-known collections like lists, sets, or maps in a new, more convenient and flexible way. What exactly are streams and how can we use them to write better and cleaner code? This is what I'm going to talk about in this video. My name is Kamil and welcome to my channel. When we watch a video, whether on YouTube or Netflix, we don't download it right away. Only a small chunk is loaded onto our computer, and as we progress through the video, the next portions are loaded just when we need them. This concept is called streaming, and it has a lot in common with streams in Java. So what is a stream? Basically, it's a sequence of objects that are computed on demand. Let's say that we have an array list containing names, and we want to create a new list that only contains names starting with the letter A. In the traditional approach, you would first create a new list, taking up space in memory, and then go through the original list and add matching objects to the new list. Using streams, it will be a little different. We will go through the original list, filter the data, but no list will be created until we reach the final step and finish all our computations. This is why we divide stream operations into two categories. They can be either intermediate or terminal. Intermediate operations return a stream that can be used for further computations, while terminal operations return a concrete result, such as an array, a collection, a single object, or a number. But enough with the theory, let's write some code and see what streams are really about. Let's create a new project in IntelliJ IDEA. I will call it Stream API. Here, language Java, build system Maven. You can also choose add sample code, but don't check this generate code with onboarding tips. Create. The new project is created, and now we have to prepare the data we'll be using to work with streams. We'll have a list of employees, and we will use this list to learn stream operations. So first I need to create a new Java class. I'm calling it employee, but let it be a record. A record is quite a new feature in Java, which allows us to write a very concise code without any boilerplate. This is something we might know from other languages as a data class, but here in Java it's called record. We want this employee to have a first name. We want it to have last name, both of type string. Then we want integer age and a list of skills which will be of type string skills. We can add a new line here and alt enter, and here is a weird thing, we don't have an import here, so I will just do it like this: import Java util list. Now it's okay. Something was wrong with IntelliJ. So now I'm going to the test package, Java, and here I'm creating a new class, streams. I'm choosing a test package because it will be just easier to have all different operations in this one test class. We'll just have one test case per one operation. First thing, let's declare a list of employees. Okay, here we can import list, I guess. Alt enter, import class. Now it works. I will call it employees new array list. Now when we have this list we'll be using in different test cases, we have to fill this list with actual data. So I will create a new method, public void set up, and inside this method we'll just populate the list with data with employees, but I will add an annotation here before each. So this setup method will be called before each test case. Alt enter. I'm choosing add Maven dependency. Here is the correct library, Jupyter. I'm clicking add. Alt enter once again to import this. And now we can populate the list. So I'm starting with the first employee, new employee. We need to give it first name, last name, age, and a list of skills. For the first and last name, I will use this Benedict Cumberbatch name generator. So I'm copying the first name, going back to IntelliJ IDEA, Barnabas, and last name, Crumble Snatch. Age, let it be 30, and list of skills, I will just put an enter here. Okay, list of skills, let it be Java and C#. Extracting it to a new variable, and I will call it employee 1. And now I will repeat this process for the rest of employees. We have 8 employees, and we can add them all to the list of employees, which is called employees. So employees, add employee 1, and now I can just copy it 7 times and change the number here. And now we have a list we can use in our test cases to show the stream operations. I've created a new method, public void first stream. Of course, we need to annotate it with test. And inside this method, we can create our first stream. So employees stream. And now I will call a for each method, which will go through all the elements of the stream for each. And I will use a method reference to print out the content of an employee object. So system out double colon print ln. Here we can see a hint from IntelliJ IDEA. We can replace stream for each with just for each. This is because for each is a specific method. We don't need to create a stream first. Every class from a collection framework has this for each method implemented, so we don't need to create a stream first. Okay, I'm running this first stream, and we can see that all employees were printed out. The contents of all employees were printed out to the console. So now we can create a second method. Also, test annotation is needed here. Public void map operation. Once again, using employees, and now we have to call stream method to create a stream out of this list, and we want to map employees into something else. A map operation works in a way that it takes elements of a stream and transforms them into something else. We can actually say that it transforms a stream of objects of a certain type into a stream of objects of another type. In our case, we want to say that for each employee, get the first name. Here you can see the arrow operator. And now for each, once again, print out to the console. But we won't print the contents of a whole employee object now, because we mapped an employee to this stream. Instead of stream of employees, like here, we now have a stream of strings, a stream of first names. I'm running it, and we can see we have first names here. And here we have another hint from IntelliJ IDEA. We can replace lambda with a method reference, so the code looks even more concise. Of course, we can map our employees into something else, so I will just go back to this, and I will add a space here, and employee last name. Now when I run it, we once again mapped a stream of employees to a stream of strings, but now this string is different. It's not only the first name, but first name, space, and last name. Of course, if we wanted to map it in this way, employee age, it will also work because we now change this stream into stream of integers. Okay, what about skills? Employee skills. Now we have this very interesting list of skills of each employee. So we know this employee knows Java and C#, this one knows C, C++, C#, and so on and so forth. But what if we wanted to have a list of skills of all our employees, but without any duplicates? Because we just want to know that we have a person who knows Java. We don't care if it's only one person or two people or more. We just want to know that in our company, we can have a Java project because we know at least one person who knows Java. So this thing is not the best because we have several lists, and I want only one list with all the skills of all our employees. For this, I will use a flatMap. So I'm creating a new method, public void flatMap operation, employees stream. Now we have to use map, employee skills, and now we need to flatten what we got. So flatMap, we have here a stream of lists of string, and we want just a stream of strings. We do it like this: list.stream, and now we can either print it all out or we can create a new list out of it. First, let's just print it out. So for each system out println run, and we can see Java, C#, so on and so forth. Okay, here we have Java again, so we will need to change it. But now instead of printing it all out, I want all this data to be added to the list. I can use a collect method. So as a last operation, a terminate operation, I use collect, and now collectors, and not to set, but to list. And look at this hint. Okay, we can replace lambda with method reference. And here we have another hint that we don't use the result of this collect method. So we have to extract it to a new variable. I will call it all skills. And now we can print all skills to the console. And now we have a list of all skills, but we also have duplicates here: Java, Java, Java. And now we have two ways of solving this. First, we can use set here, because in set we don't have duplicates. So changing list to set. It worked. And the second way is to use distinct method on a stream. So now even if we have to list and list here, we won't see any duplicated values. You just saw a distinct method. Let's see what are the other methods we have in streams. Another test, public void filter operation. employees stream. And now, as you can guess, we can filter out some of the results. So let's say that I want only these employees whose first name starts with, let's see what we have here, with B. And once again, for each, system out print ln. And we only got 4 employees this time. All of them have a first name starting with letter B. Now maybe we want to sort the stream. So once again, I'm creating a new method, public void sorted operation, employees stream sorted, and I want to sort them by age. Comparator comparing employee age for each, system out print ln 20, 23, 24, 28, and so on up to 42. If we want to sort the elements in a reverse order, we need to pass in our custom comparator. So new comparator, and now we'll do like this: o2.h minus o1.h. And let's look at the hint. We can replace this whole anonymous class with lambda. And now we have a very, very simple piece of code where we pass in 2 elements, 2 objects, object 1, object 2, and we take an age of this object and compare the age of a second object with an age of a first object. And now when we run it, we can see that the oldest employee was printed out as the first. Another cool method is limit. So limit operation employees stream limit, and let's say 2 for each, system out print ln. As you could expect, it will print out only 2 elements from the stream. And there is a similar method called skip. Test public void skip operation. Employees stream skip, and let's say that we want to skip the first 3 elements. Let's print it out. And let's see here. We had Barnabas, Carly Cooch, and Honky Tonk, and then Fiddlestick. And here we have a Fiddlestick because we skipped first 3 elements. The next operation is a count operation, which counts the number of elements in a stream. Count, and now we can assign it to a variable, number of employees, let's see the hint. We can also replace it with collection.size. That's true, because we didn't do any operation on our stream. But I will go back to this. I will run it. We have 8 elements of a stream, and now we can do something with the stream, like filter employee get employee first name starts with B. And now when we run it, we can see that we have 4 employees whose first name starts with a letter B. Another 2 terminal operations are min and max. So once again, employees.stream. And let's try with min first. We can see that it expects a comparator. So comparator comparing employee age, run. Of course, I didn't do anything with this. I will assign it to a variable employee, and we can see that this min method returns an optional. So in order to actually print the information about the employee, we need to call get. And we got the youngest employee, Carly Cooch, Camber, Sniff. If we want the oldest one, we will just change min to max. And now we have the oldest employee, Bombadil Chicken Broth, who is 42. The next 2 operations, findAny and findFirst. findAny, findFirst operations. Employees stream. Now let's filter employee first name starts with B. We'll stick to this example. And now findFirst, it also returns an optional, so I will just call get. And now we have this employee here, employee 1 actually, because employee is already defined here. And system out println employee 1. Barnabas Crumple Snatch. If we change findFirst to findAny and run, we'll also get Barnabas. We also got the first match. Does it always work like this? Yes and no. If we have a non-parallel stream, in most cases, we'll get just the first match, but it's not guaranteed. So if you want to get the first one, always use findFirst. Now, if we add parallel here, so the operations on the stream will be done in parallel, we can get different results every time. Now we got bumper stump. Now we got bumper stump again. Let's see. Yeah, usually we get now this bumper stump. There is something, going on in Java virtual machine that it always returns this guy. But if we put findFirst, we'll get Barnabas. It's just the first match which was found here. We also have very similar operations, allMatch, anyMatch, and noneMatch. So let's create a new method here. allMatch, anyMatch, noneMatch operations. Employees.stream, and now allMatch this condition, employee first name starts with B. And this is a Boolean value. Let it be B and print the value in the console. We get false because not all of the employees have a first name starting with a letter B. But if we change this to anyMatch, we'll get true because we have some employees whose first name starts with B, and noneMatch, it will be, of course, false. But maybe if we put a letter Z here, yeah, we'll get true because we don't have any employee whose first name starts with a letter Z. And there are two other methods I want to cover in this video, takeWhile and dropWhile. So let's start with takeWhile operation. takeWhile operation employees.stream. And the first thing we need to do is to sort the stream. So let's sort it like this. Comparator comparing employee age. So we will sort the stream from the youngest employee to the oldest one. And now we can say takeWhile employee age is less than 30. And for each system out print ln, and we get 4 employees. So we only process a stream while employee's age is less than 30. If we change takeWhile to dropWhile, we won't be processing the stream when this condition is fulfilled. So now when I run it, we can see also 4 employees, but this one is already 30 and then 33 and so on and so forth. So when the age was less than 30, we didn't care. That's all for today. Thanks for watching and don't forget to watch the next video, which you will find here.